So, hello everyone. First of all, I'm very happy to be here, and thanks a lot, Anders, for the invitation and the opportunity. So, I will try to cover these topics, starting with what I'm calling like my safety moment, a holistic consideration about the energy transition. Then I will make a point on deep geothermal system and why I believe that there is really a call from moving from conventional and start developing what is currently also named like geothermal anywhere. I will then discuss a bit the AGS, so Advanced Geothermal System Design, closed-loop design that we develop, some low-hanging fruits for potential faster deployment, and then basically also the reason I'm here is to talk about this EPO so an open lab initiative to realize advanced geothermal systems. So, first of all, this holistic consideration. Personally, I'm not a big fan, or I don't believe the term energy transition is the right name for what we should do if we were serious about phasing out fossil energy. It's more about transforming our society. It's a paradigm change. I'm trying to illustrate this with this graphic where you can see on the I never know left or right, that side, the historical perspective of the global energy consumption, and where you see very clearly that actually we never used and consumed as much coal, oil and gas since we invented the concept of sustainable development. Now, on the other side, right side, I just copied the emission reduction slope for a 1.5 degrees global warming planet. This is how fast we should move out. Nevertheless, I'm a positive person. I think that geothermal has a great potential in that context. First of all, it can add a new form of energy that is available everywhere, that is base load, low carbon, local, dispatchable. We all know this here. It can supply both heating, cooling, and electricity. But watch the color code. I use actually green for the other thing. I think geothermal could be used to really shift away from the oil and gas industry by taking the people, the rigs, and start to drill to produce heat instead of drilling to produce oil and gas. Now, another aspect about geothermal is on this periodical table of the elements, you see how clean energy is looking like, the impact. And just to recall, the mining industry is actually the most polluting industry, and there is nothing we can do to change this. And in that context, geothermal comes actually pretty good out. It's not so mineral or metal dependent. Lots of steel, of course, but the rest is pretty okay. And to me, in a world where supply chain, this is also about supply chain vulnerabilities. We have increasing uncertainties. We have increasing extreme weather events. It really makes sense to try to develop robust and simple energy solution. And geothermal, I think it has it, because if you think about it, it's about circulating water in underground pipes, and that's it. Also because geothermal energy increases the energy autonomy of a region. It can reshape the geopolitical landscape, and this is why I'm proposing the tag like geothermal for peace. We should go for that. Now, about deep geothermal. So I'm not talking about heat pumps. I'm not talking about conventional geothermal on like geysers or volcanic area, but just the spectrum of application of deep geothermal. Of course, when you have like an aquifer, you have to go for it. But I came across a publication from, it's written here, Braun et al., 2012, Mining the Earth's Energy, where they evaluated that actually the aquifer resource is 0.01% of the heat that could be recovered, that the heat that is stored in hot rocks. And so I think this is really the argument for us to say we have to develop these non-conventional approaches in geothermal. And so from enhanced, just a word, so this is the one with fracking, where you try to create a reservoir and circulate, like copy what is already done with nature, and these are the closed-loop solution. I have the feeling that at the end of the journey, we will end up with a continuous spectrum of application, because geology is very diverse, and for each region, we will have the perfect application. Now, how can we start, and what are the low-hanging fruit? And this is kind of a personal perspective, but I really have the feeling that there is a case for enhanced geothermal system in the US and for advanced geothermal system in Europe. In the US, if you look at the governmental reports, they are targeting, so they have very aggressive targets on electricity generation by geothermal by 2050. They are targeting up to 90 gigawatt electricity. This is like 3 doublets with 2 megawatt electrical capacity to be deployed per day, starting last November, because this is when I calculated it. But still, I think they are going for that. The Department of Energy is injecting money. They have the Utah Forge Laboratory with great results actually on the drilling aspects. Fervo Energy, great results on the enhanced aspect. And I think it could make a good point for transferring the big fracking industry they have over there, if you consider that there are signs of Permian Basin depletion. Now in Europe, the situation is a bit different. I think the people, they don't really like the fracking. At least this is the situation in Switzerland. We have thousands of existing district heating networks, mostly running on gas, and heat is actually 50% of the global energy demand. Now, district heating requires lower operational temperature, so it means you don't need to drill that deep. So it's easier to achieve. And then because we don't, so with advanced geothermal system, there is no fracking, it means that it can be deployed within community or very close to communities. So I really think that district heating network is the natural entry market here, and that electricity, maybe we will gain some shares when we learn actually to make the systems. So here I'm presenting a bit the design we have. So it's closed loop, but it's multiple legs closed loop. Like it was said before, basically since it's on conduction only, the only way you can increase the capacity of the system is by increasing the length of the lateral you have built down there. And currently, to my knowledge, there are 2 companies out there doing this. It's Ever and it's us. Ever, they already have like pilot projects. We are still on the PowerPoint. And the difference that we have with them is that we use what we call a service well, so a third well, from which we want to deploy the laterals and connect to the injector and producer well. What we want to be able to do is, as soon as the first layer is completed, we have a loop, we can start operation, and with the service well, we can continue to incrementally drill and increase the capacity of the plant. I have provided like some high-level figures. We all have the same physics underground, and so this is quite conservative calculation, but it gives you the target. If you want a plant to generate heat and electricity, if you deploy it at 150 degrees C, so it's more or less 5 kilometers depth, we are talking about 50 kilometers of lateral to produce 10 megawatt thermal, 1 megawatt electricity. But this is for like ever. You will have to use very slow, low flow rate, so half a liter per second per kilometer of lateral. If you want to use the system to produce heat, then it's another story, because you can push a bit higher on the flow rate to generate the heat. I wanted to give an example, so make an equivalent of an existing geothermal installation. So this is a real geothermal installation in Switzerland, hydrothermal, so it's in the Muschelkalk. It's 1 doublet. They produce 25 liters per second at 66 degrees. They have 1 heat pump. They use it to increase a bit the temperature of the system to add some megawatt thermal output. And here you have the so the yearly profile of the heat demand and how it is supplied. And you see that actually, so the geothermal component is really providing the base load component. And in that aspect also, I believe that geothermal is a good fit for the base load. For the peak load, I still believe that we will need some kind of high density fuel to cover this part. Now, if we want to do that system with an AGS, it's with the EAPOSYS design, it would be like 3 levels accumulating 24 kilometers of lateral, deployed between 2.63 kilometers depth under a normal geothermal gradient, and this is enough to produce 25 liters per second at more than 60 degrees for more than 100 years. And this is what you see here. So you have the flow rate and on the vertical axis the temperature or the power output in megawatt thermal, and you see that when you increase the flow rate, actually you will deplete the temperature a little bit, but still you have time to go. Now, this is not my last presentation, I realized. I sent you another one, I think, but no problem. So coming to the EPOLab initiative, so we realized that actually this is what is needed, a deep geothermal alliance. It's about creating a new industry, so it's about creating the community and the people. And so we developed a business model that enables us to work like in a distributed way. We are not verticalizing, and so actually part of our job is to be the catalyst of this initiative. And the objective is to have like these EPOLabs, so each EPOLab is an AGS production site. We don't want to have the testing. We think testing is like, we don't have time for this. So we want our system to be operational directly, but then the lab is also for system optimization and learning. Now, the objective of the lab is also because energy is linked to territory and comes with different regulation, policies, and so on. We want each EPOLab to provide the reference deployment guide once we have de-risked the technology, how we can deploy the technology in the region, how it's going to best fit in the local energy mix. We have started this core consortium with these partners, so we have had like 1 year plus discussions, and this is how I actually arrived here, because a discussion with Anders. By trying to find a potential location in Norway, Svalbard name came out, and I have to confess that I kind of fell in love with the idea, because I really think it makes sense indeed to make geothermal over there for political reasons, for the context, moderate peak load need, but also, and this is my favorite one actually, because it's going to be difficult, and I think this is about the future. I mean, difficult condition, difficult supply chain, I'm pretty sure that this is going to arrive, and so it's a very good exercise to do this in Svalbard. The impact could be pretty big. I mean, Norway could take a leading position by putting some commitment on the table and say, okay, we are going to phase out oil and gas. There is a direct transfer potential to, this was already said, Arctic community, insulated communities. And we envisage as a funding, so the Innovation Fund, very large-scale project with capex in excess of 100 million. But basically also because the place is very iconic, I think I'm pretty confident that we could find some kind of alternative financing scheme with foundations, donations, ultra-high net worth individuals, or sovereign state fund. This is my last slide. I wanted to show what we have in mind, a little bit very high level design for Svalbard. So the idea would be to go and demonstrate a project, a pilot where we have already like 2 levels, taking in mind that we want it to be not too big in order to de-risk the maximum. Target would be, I think this is maybe a bit conservative, but 1 megawatt thermal for plus 100 years. So in a very sustainable way, we don't want to deplete the resource. The cost, of course, preliminary are very, yeah, indeed, I corrected that. So pessimistic is, no, sorry, I'm reading correctly. So between 40 and 60 million to 1 megawatt thermal. So it's a lot. But then I think we should also consider that basically what geothermal can provide as a value to society. Reliable energy, always there, no fluctuation on the price, and so on. And I think I will end up here. I don't know, have I?
You are okay, yes.
I'm okay with the time?
Yeah, you can have 1 more minute if you want.
Okay, yeah. So on the realization strategy also, what I think is important is we should narrow the problem down to an engineering problem, because I really have the feeling now I'm starting to discuss with drilling engineers and so on. The technologies, they are there to do that. They already exist. So it's just a question of using these technologies to do something new. And so engineering problem, and then the R&D and all the optimization would be the research part of it. But yeah, this would be the idea. And thank you for listening.
Yes, we have time for questions. Yeah. Yes, question? Yep.
This is really, this is the very long-term target. If for a system that would be able to produce electricity plus heating, and in a way that you are not depleting the system. If you want to make a system that is operational for 30 years, you can maybe cut it by 2. But I don't think 30 years, if you have drilled that long, is sustainable. I don't know if this is going to happen, but I mean, when I look at the current situation, it's worth to evaluate at least the possibility. And now the 24 kilometers, this is this is layered. And when I see what the oil and gas industry is able to do to recover oil and gas, I'm saying to myself, it should be feasible to recover some heat. No, this is 1.2, between 1.2 and 1.5 kilometers maximum.
Which is well within today's durability. It adds up to
The 24 kilometers here that I discuss here, this is a district heating network that has been working for more than 30 years, supplying heat and hot water for 8,500 people. So it's already kind of a big system. Now, if we start with a smaller system, you don't need the 24 kilometers. Low risk profile.
Philip?
Yeah, great presentation. I guess from the feasibility point of view, I tend to agree that's not something which is unrealistic. I guess also we have to consider the learning curve. I guess Bear addressed a little bit that on the doublet I've been doing, but you optimize the bits, you optimize the well control, you optimize a lot of things by just accumulating the wells. So this is not just one well, this is multiple wells, so we need to account for that. And also, when we look at Ever, they have managed to start the pilot. Then in Geretsried, this is, it's heavily subsidized, but I mean, this is what we need, right? If we want some changes. So.
Maybe Ever, the project Ever in Geretsried, they started very big directly, and I think, but I mean, they have drawn the attention. We are talking about them, and this is also a good point. I mean, there is no way we are going to learn if we just say it's impossible.
How long do you expect the drilling operations to last? I guess in Geretsried that would be several years, like.
Yeah, this is the order. Like we consider for one installation, it's like at least 3 years of construction. But this is also the idea about being able to go incremental. That is, because we know there is a lot of drilling operation, we want to be able to start supplying some heat and then continue to increase the size of the system.
Yes, thank you.
Thanks.